So we're live. Hello, Svetlana. Hi, Christian.
Hi.
Hello, Mark Reichelt. He seems to be now on the. It was one of the 11 people on the YouTube stream. So, well, thanks everybody for joining. Nick will join later. He's our third speaker. And today on our March 2021 edition, we have three top speakers: Christian Zbiura from Novatech, Svetlana Isakova from JetBrains, and Nika Skelton, freelancer and a Google developer expert. Christian will be talking about supersonic subatomic mocking. Svetlana will be presenting the new language features in Kotlin. Is that Kotlin 1.4, 1.5?
1.5 is coming.
Great. Svetlana will be presenting the new language features. Sorry, I have the YouTube on the background. And Nick will be talking about how can we use flow in Android V models. So, Christian, you're going to be our first speakers.
Yes. Should I share my screen already?
You are not sharing it yet. As soon as you share it, I will put it into the stream. To all the attendees, please feel free to write anytime on the YouTube questions. Christian will read it when he's done with his presentation, and he will tackle some of the questions as we see that we have time for them. So, Christian, the stage is all yours. Thank you very much for coming, and good luck.
Thanks. So, you should see my screen so far. Okay. Welcome from my side. I'm going to talk a little bit about Kotlin on server side. To be more precise, I call it supersonic subatomic mocking. We're going to have a look at a Quarkus app written in Kotlin and how to test parts of the Quarkus app with JUnit and Mock-K, and Kotlin as well, of course. So what can you expect within the next 25 minutes about something about that? I try to give you an introduction how to create isolated tests for Quarkus app written with Kotlin. Isolated, I mean, you won't see an end-to-end test where you test your application from the REST controller way down to the database. We just say, okay, we want to test our REST controller, or we want to test a service, something like that. We're going to mock stuff around that. For that, we're going to use JUnit and Mock-K. Don't worry if most of you probably heard of Kotlin, as this is a Kotlin meetup. But if you're not heard of Quarkus or not familiar with Quarkus or JUnit or Mock-K, I give you a short introduction to these technologies, but you won't get a deep dive into this because there are way better introductions to all of these technologies you can find on YouTube or any blog posts, etc. I'd rather show you today how to combine these to test your application. And I try to give you some practical insights, so we're going to see some source code, obviously. And a disclaimer way up front, what you see is how we manage to test our application. So see this as an inspiration and not a silver bullet or best practice or how things need to be done, because perhaps in your context it suits, perhaps in your context it's completely wrong to do it that way. So yeah, this is how it works for us, and perhaps it's an inspiration how you can test your applications. So before I give you a brief introduction into Quarkus, I need to do a short excursus because Quarkus claims to be very resource efficient. And for that, I need to say what I mean with resource efficiency and why it is important. First of all, from my perspective, resource efficiency has two dimensions. The first one is the startup time of your application, and the less startup time you need, the better, and the memory consumption, which means the less memory you need, the better as well. So why is this important? Well, if you have an application, an EAR, you deploy to your application server, which the process runs for hours or days or weeks. If your process runs for weeks, it doesn't matter if your startup time is 5 or 10 minutes. But nowadays, you're in these distributed microservice environments where your cloud decides to start an application now, because there are coming new requests in and you need to dynamically load new instances. So this horizontal scaling instead of vertical scaling, or perhaps you have a failover strategy. Your instance crashes and needs to be started immediately. Or perhaps you have the CI/CD approach where say we deploy to production several times a day. And if your deployment takes for ages, that doesn't really fit. So especially if you're in a container where you have not that much resources, you normally just have one CPU and not that much memory, it matters if you have a lot of instances running. And it matters even more when you go towards serverless or this function as a service, something like that, where you have this scale to zero approach, where say the first request starts my instance. And if that takes 2 minutes, well, that's not applicable. That's not working. So if in serverless, cold start time is really a crucial factor. And concerning memory, well, you could say we're in the cloud, we just buy more memory. At the end of the day, you have to pay for it. And if you say, okay, I have 5 instances running of a service, and each instance needs 1 gigabyte or 2 gigabyte, that's a different. But on the one hand, you need to pay more, or with 5 gigabyte or with 10 gigabytes, you can run 10 instances if it just needs 1 gigabyte. So resource efficiency matters in these microservice containerized environments. Or to say with this Twitter tweet, the less efficient your application, the more profit the cloud provider makes. So keep it in mind, it's kind of important. Coming with that, I'm going to give you a short introduction to Quarkus as a very resource-efficient framework, and it says about itself, we are supersonic, subatomic Java. And these 2 words already describe a lot. Supersonic means very fast, and subatomic means very small. So it starts fast and needs not much memory. Or to say it in a more general way, it's a full-stack framework tailored for the OpenJDK or hotspot or the Graal VM, where you can create native binaries, which even are more resource efficient. It is Kubernetes native and has this whole container-first philosophy, which means you get the artifact you generate is pretty small. So your Docker container is not that big. You have good startup time, and you have low memory consumption. And how does Quarkus reach that? How does Quarkus manage to get these good effects? As Quarkus places himself pretty much as a component or competitor to Spring Boot, let's say what Spring Boot does and what Quarkus does differently, and I think you're going to see what happens. Spring Boot manages to resolve its framework logic mostly by reflection, runtime proxies, class bar scanning, dynamic class loading, all powerful tools to create a framework, but they come at a cost. And the cost is your startup time is not that good. If you do a lot of stuff at startup time, obviously your startup time increases. And if you use a lot of reflection, your memory consumption at runtime is probably not that good. And frameworks like Quarkus or Micronaut, by the way, try to get rid of reflection and runtime proxies and all that stuff and do resolve the framework logic at build time or compile time. So when you start the application, it's almost reflection-free and runtime proxy-free. So with that, they get these advantages concerning startup time and memory consumption. One last remark to Quarkus, we're going to use that later on in the example. The dependency injection framework of Quarkus relies on CDI. It's not the complete CDI, it's a subset of CDI, the context and dependency injection. If you ever work with microprofile or JEE, you probably heard of that. So we're going to see that later on. The second technology you're going to see today is JUnit or JUnit 5. I assume most of you have worked in the backend have used JUnit, or at least have heard of JUnit so far. It's a very powerful or very handsome, very, very good to use testing framework, at least since version 5, and it focuses on Java 8 and above, the versions above Java 8. And the good thing is almost all the functionality you can use in Java, you can use the same way in Kotlin. And well, I'd say some things even are better in Kotlin. There are some flaws, some things you need to take care of. We're going to see one of these later on in the example. And the third technology you're going to see today is Mock-K. When we're going to try to create these isolated tests, we just test a REST controller or just a service, and everything around it needs to be mocked. We don't want to take care of that. You need some mocking framework. And if you come from Java, you perhaps have used Mockito, and there is an extension for Mockito for Kotlin, but Mockito was primarily built for Java, and therefore it has some flaws, some drawbacks, which you need to take care of. And if you have the choice, Mock-K is designed primarily for Kotlin, so you have this really nice DSL to describe your mocking behavior. You have no problem with final, which is the default behavior in Kotlin, so I really can encourage you to use Mock-K. So this was the short introduction. Enough of words. I'm going to show you some code, and therefore I've prepared a small demo. So it's really rather a hello world demo, but what you're going to see, we're going to have a REST controller here which just receives a GET request, and it has injected a main service, a CDI bean, you're going to see later on, which itself has also injected or was injected with a subservice, also a CDI bean. So this is what we're going to see right now and what we try to test. We're going to try to test this main service isolated without its dependencies to subservice, and later on we're going to test our REST controller without the dependency to the main service. Okay, let's switch here. So this is the application, and you see here we have a REST controller, and there are different ways in Quarkus to describe a REST controller or a REST endpoint. You have funky, and we use here REST Easy, which is an implementation of JAX-RS. If you look here, from which package this is just JAX-RS. And if you're familiar with Spring Boot or Micronaut or any of these annotation-based frameworks, you probably feel familiar here. We just say this is the REST controller. It runs on a certain path. Here we have, if a GET request receives us on this path, we produce some JSON, and this function is executed. What does the function? Well, we just say use the main service, which was injected here with constructor injection, and call the say hello method here and wrap the answer in a greeting response. So far, nothing really special. And if we look at this main service, say hello here, this is now a CDI bean. You see here, application scope, this is marked as a CDI bean. If you look in that one, this is really from context, yeah? And this itself has also constructor injection here with a subservice, and this just returns, ignore this cache result for the moment. We're going to have a look at that later on. But for the moment, just say, okay, this says hello, and also calls the subservice, which calls say hello, which itself is again a CDI bean, which just returns hello from the real subservice. So I've already started this application here. Here. And so when I do a curl here on localhost 8080 hello, it should return hello from real main service, hello from real subservice, nicely in JSON. So far, nothing surprising. So what we try to do now is create, first of all, a isolated test for this main service. So isolated means I don't want to test the subservice. This needs to be mocked away. Just test this little bit of logic here. Well, logic is a big word for what's going on here, but you see, I just want to test this here. Okay, so we create a test, main service tests. And I just created some live templates, so I don't need to type everything, because you're going to see I'm not really fast in typing. And the easiest thing, if you want to test this service, is just create a plain unit test. Yeah? This is what you see here. I say I need a mock kmock of the subservice, and I'm just instantiating my main service here and hand over here my mock. So this is replaced with my mock. And now I can define my test. And this is, if you not have seen JUnit before, this is a test class, and this is a test function here, real test. I just annotated with test. And I can say, okay, and this is the mock DSL, every subservice say hello call returns hello from the mocked subservice. This is just the AAA pattern. Arrange, act, assert. Yeah. So we say here, arrange the mock, execute the test, or act, and assert here. This is just with assert J. You can also use assert K or what you like, and say the result should be hello from real main service and hello from the mocked subservice, not the real service. So if I execute this, this should run rather fast. And normally, if you stream your screen, nothing is really fast on the machine, but as it's just a plain unit test, it should be fast one. Okay, and it passed, so it works. So now imagine, going back here, we have something like this. We say this needs to be cached, this function. Well, in this trivial example, that makes no sense because this is calculated in nothing. Yeah? But imagine the subservice would do a very long-running calculation or call another service or something like that, which takes really long. Then you can say, okay, cache this, and the first call is executed, and the second call use the result which is already in the cache. So, and now in my test, I want to say, okay, I don't just want to use the behavior, but also the caching. So I say here, let's call hello, say hello with mock subservice and see if caching works. So we call this 2 times, results 2, and just copy that. First, the second result should be the same. And we can say verify exactly once, subservice, say hello. Okay, need to import this. We say, okay, call it 2 times. The result should every time be the same, but the subservice is just called 1 time because it is cached. And if I run this, spoiler alert, it should fail because if I just do a unit test, it knows nothing of the cache result annotation because that is a Quarkus annotation. So I need the framework, I need the application. Yes. So see, okay, subservice was called 2 times. Yes, of course, it was called 2 times because this is a framework annotation. So what we need here is rather a isolated kind of integration test where we start Quarkus in the background and we have a real application running and our test against an application. And what we do here is say Quarkus test. If you're familiar with Spring Boot, you probably know Spring Boot test, which kind of does the same. We just say start the application, and this is not done by dependency, not done by instantiation here, but with, we say here, and inject. And this needs to be a late in a var in that case. And I can try to run that. We're going to see some stuff already. First of all, you're going to see it takes longer to execute this test because Quarkus is really started in the background. It takes way longer. But I can assure you, this is not the normal behavior. If you don't stream your desktop, this is normally much faster. But you see here in the log already. Okay, let's do the assertion first, and then we have a look at the log. Yeah, you see here, Quarkus is really started within 4.5 seconds. It only takes about 1 or 2 seconds. It runs on a certain part here. And the assertion fails because it's still using the real subservice and not the mocked subservice. Because, of course, we just defined here a mock, but we have never told our application to use this mock instead of the real CDI bean, which there is. So what we're going to do here is say we use a before all, set up mocks. And this is a helper class from Quarkus, which says Quarkus mock, install mock for type. And we say, whenever the subservice, the real subservice is used, instead use this mock we have defined here. And I can try to run this now. It still fails, but with a different error. And it says before all needs to be static. And this is the difference if you use JUnit in Kotlin than if you use JUnit in Java, because in Java you just say this is a static function. In Kotlin, static behavior is differently from Java. So the easiest way is to say here we make this a companion object. And we can say here this is JVM static. So, and we run it. So what happens now is the mock should replace all CDI beans of type subservice. And we have defined our mock behavior here. We call it 2 times, but hopefully the subservice is just called 1 time. So once again, Quarkus is started in the background. Okay, it works. So we've tested, we've seen that caching works, our annotation is correct. But to be honest, I'm not really a fan of this companion object here, because in this, if you do it like this, you have to write more code than you would with when using Java, and that's rather unusual. Normally, Kotlin is very concise, and you don't need to write that much code. So one way to get rid of this is just to say, do it like this. And you say, okay, JUnit, use test instance, and not the default per method, we use per class here. And in this case, this method does not need to be static. So this is the more precise or more smaller way to define this. Okay. Still takes some time to execute everything. Here you see Quarkus is started. You see also the features that are installed with it. And cross your fingers, the test is green. Nice. So this is the official way how to get your mocks into your or to replace your CDI beans with your mocks. This is the official way. Nevertheless, there are some things that are not so good working when using mock-K, and therefore, a couple of weeks, I think 4 weeks ago, not 2 months ago already, there was in Quarkiverse, which is kind of the, well, it's not a playground, it's a place where you can create extensions which might become an official extension of Quarkus, and there was a Quarkus JUnit 5 mock-K extension. We're going to have a look at that because it's really handy, easy to use. But just one, let me have a short disclaimer. This is just in version 0.2.0, and there are only 2 guys working on that. This is me, this does not count. This is a bot, also doesn't count. These guys are working on it. So it's really promising. It looks nice, but so far I'm not sure if I can say, yes, take it with, this will be supported forever. So the nice thing is, if we want to get rid of this and this, and here you just say var. Now I don't want to care about this. Let's just say here inject mock. So create a mock for me and inject it in my Quarkus app and replace the real CDI bean. So this is, I just started. I can talk while it compiles. So I think this is a really nice way to describe your test. Define your mock, define your testee in this place, define your mock behavior, execute your mock, and have your assertions here. So a really compact way of defining your isolated tests. Okay, and it works. Nice. So what else we're going to do? We're going to create a test for our REST controller, which is not really different, but at this part, it does not make sense to have a unit test at all, because what we're going to test is here is can I reach this path with a get, and is what we're going to get back JSON, and is everything serialized nicely, etc., etc. So this need to be a Quarkus test, because unit test is not sufficient at this place. So we create here a, oops, already created, okay. Let's do it from scratch. Create here a REST controller test. REST controller test, and have a look at that. So once again, we say it's a Quarkus test. So the application is the application is started. For the moment, I say this is a test instance per class. So this does not need to be static. We define now our mock as main service. We can test our REST controller, and we want to mock this part here, and set up the mock and say replace the main service with our mock. And now we say, okay, test. Every main service returns hello from mock main service. And then this is rest assured, this is nothing Quarkus special. This is just if I call if I do a real HTTP request with get against the endpoint hello, then status code 200 should be returned. The content type should be JSON, and this is what I expect to come back here. So expected JSON should be what is in there. And if you look here, yes, status code 200, and this is the wrapper object for our return. So it should be working. And the second test here, just before I run it, we can also test here if the main service throws in runtime exception that when I call hello, this is mapped to a status code 500. To be honest, that the framework manages to map runtime exceptions to status code 500 is rather not really useful to test. Imagine here that this is your own user not found under certain circumstances exception or something like that, and you map it to your 404 or something like that. So what you might want to test in your REST controller is if a certain exception is mapped to a certain status code. This is just a very easy example. So I run this. And once again, Quarkus is started, and now we do real request against our REST controller and see kind of integration test if our REST controller behaves as we expect it to be with a mocked main service. The main service is not tested with it. Okay. And of course, also here, if you don't like this, you can create here at inject mock with the, no, we don't need this. This can be a create init var. We don't need this. This, of course, works also. We just say create this mock for us and insert it into our application and rerun it just to prove that it's still working. On. Okay, that's a green. Application behaves as expected. So, yeah, what you've seen is a isolated test just for one unit, a REST controller or main service of our Quarkus application. Okay, and with that, let me switch back to my presentation. Well, if you decide, or if you think about switching to Quarkus, because it's a nice framework, it's really good to use, it has lots of libraries you can use, etc. There are some things you need to be aware of, and the most important, I think, is that Quarkus is around for about almost 2 years, since 2019. So, of course, it's not there where it's a framework like Spring or Rails, which exists for forever. Concerning feature completeness, ecosystem, documentation, etc. It's not there yet. There's a lot of going on in the framework development, a lot of drive in there. They're putting a lot of money and energy in there to keep up, but it cannot be there yet. And to be completely honest with you, it's primarily supersonic, subatomic Java. It works with Kotlin. Yeah, of course it works with Kotlin. You've seen that. But if you look at the documentation, most of the documentation is written in Java examples. You find lots of Java examples and not Kotlin examples. And sometimes it's a little bit tedious if you take the Java example, transform it to your Kotlin code, and it's not working. And you start to wonder, did I transform the Java code wrong to Kotlin, or is there a problem with Quarkus? So yeah, a lot of the documentation, other examples are still Java-based. I talked about this extension you've seen, which is really promising, but so far, yeah, well, it's test extension. So it's not like don't use that in production. It's just your test code. You can use it, but so far I cannot say this will be supported how long. Okay, and that's it from my side with a short introduction into server-side Kotlin, testing your application with JUnit and Mock. If you're interested in this whole stuff, I wrote a blog post about it The Mockey extension you've seen is not yet in the blog post. I try to edit as soon as possible. It's more, you have more code examples how to define your behavior into unit, etc. And the whole example, with including the Mockey extension examples, can be found in my GitHub repo. And with that, I'm looking forward to your questions. Yeah. So, perfect reason for switching to an M1 Mac. Yes, need to talk to my employer probably that he buys me one. You can even hear the fan spinning. Everyone can relate to building a screen sharing at this. Yeah, that's true. And somehow, the question is, we can hear the fan spinning. Everyone can relate to building and screen sharing at the same time. That's I got the feeling it doesn't matter if you're using StreamYard or Zoom or Teams. Yeah, it's always the same. Further questions? Otherwise, of course, I'm still around and you can ask me later on or just contact me.
So thank you so much, Christian. Folks, if any of you have questions, I guess, Christian, they can ping you on Twitter or write later on this channel. And yeah, you can jump into any interesting topic that people might be asking. So thank you so much for making the time. Very interesting talk. Thanks also for Novatech for coming up with proposing you as a speaker and talking about this topic. Next speaker is going to be Svetlana.
Hey again.
Hello. Svetlana is for the Munich communities. We already know you. You've been in a few meetups. You're working at JetBrains and directly in the Kotlin language, if I'm right.
I'm a developer advocate, so I'm advocating Kotlin, and doing such types of presentation is exactly my job.
Great. So I think we cannot find any better person to talk about the upcoming features on Kotlin. So Svetlana, everything yours.
Thank you. So I think you can see my screen. Now it's a presentation. I will try to look at the questions if you have any, but with some delay, obviously. So hi everyone, I'm Svetlana Isakova. I'm developer advocate at JetBrains, and you can also know me as a co-author of 2 books about Kotlin, Kotlin in Action, and now we also have Atomic Kotlin, which is suitable for, especially for novice developers. Today I want to talk about the Kotlin roadmap and focus mainly on the upcoming language features. So let's start. Kotlin roadmap describes the key areas the Kotlin team is working on right now and is going to focus on the nearest future. This information is available online and is open for everyone, so you can find it by this link. Time frame for these plans is around half a year. Note that it's not 100% promises. You can think of it as a declaration of intentions, and you can find there what's on the radar, what's planned, and what's got postponed for later time. And after 1.5 release, we'll also update it with some new planned information for the next period. The majority of the Kotlin team is working not on adding new stuff, but on improving the overall experience. We have a huge community, and we want kind of make life of the community easier and better. That includes speeding up the development process, making change, test, debug cycle really fast, rewriting the Kotlin compiler. You probably already heard this writing Kotlin compiler story from KotlinConf, keynote announcements, and so on. A new compiler is optimized for speed, parallelism, and unification. Later, we'll also work on pluggability. Some parts are already there, like new type inference algorithm in Kotlin 1.4. Some parts are almost there, like new JVM backend, and some parts are in active development, like the new front-end logic. And also improving the stability and performance of Analogy ID under the studio is an ongoing process, and we have quite a bunch of improvements here. And using this time, in this presentation, I want to ask you to try new Java MyR backend. It's becoming default in Kotlin 1.5, and we'd be really glad if you could turn it on in your project and make sure everything works. So it's like kind of the last chance to try it, to beta test it, and share with us feedback. So if something doesn't work for your tricky corner case, please immediately share that with us. It is surviving this late stage of stabilization. It's already used by Jetpack Compose, and it is important for its stabilization. So yes, in 1.5, it's going to be by default. In 1.4, the stabilized version, 1.430, you can switch it on by using the following setting. Everyone knows that Kotlin is great for Android development. We find it also important to spread the knowledge about using Kotlin for server-side development. Thanks also the previous talk in this meetup. And of course, one of the other priorities are like things standing in the Kotlin roadmap is Kotlin multi-platform mobile that allows sharing code between Android and iOS. I also want to mention that we started to collaborate more actively with the community and gather and publish your Kotlin stories. That includes both server-side and multi-platform mobile. You can, I would say that it's often more important to listen to what other people say about their experience than listen to our own praising speeches. And such page can probably convince some folks to convince their teams and to find arguments like what other people, what other teams are already using it. And of course, please please share with us your story. We'd be very interested to and very glad to add it to this page. So in the rest of the talk, I'm going to focus our attention on the upcoming language features. They're mostly connected with improvements in the JVM platform. So agenda for today. First, we'll talk about field interfaces and field classes improvements. Then we'll recall what inline classes are. They're available for some time already in experimental mode, but now I will explain why they became a special case of value classes. And these features will be introduced in 1.5, but you can already try them in 1.5 milestone 1 or in 1.4.30 by specifying the 1.5 language version. So let's start. And now there are questions, I think, for the previous, for the previous talk. So let's start, let's continue. Sealed modifier, just a quick reminder, I'm sure everyone knows what is it, but as a quick reminder, sealed modifier on the class restricts a class hierarchy to given subclasses. And it then allows to perform exhaustive when checks, no need to add the else branch. The compiler automatically checks that all the classes are present. If you add a new subclass, such when check becomes an error, so the compiler makes you update the usages. In Kotlin 1.4, sealed classes come with two sometimes annoying constraints. First, you can't define a sealed interface, and also all the subclasses should be located in the same file. When your logic, logic of a classes starts to expand, it's quite inconvenient to keep them all in the same file. So Kotlin 1.4 fixes both these constraints. First, sealed interfaces are going to be supported and introduced and supported. Second, all the subclasses should be located in the same package and in the same compilation unit, which means they can be in different files. So more details to both these features, to both this functionality. Sealed interface, like a sealed class, is used to define an algebraic data type hierarchy. One class can now implement two different sealed interfaces and be used for exhaustive checks for two different hierarchies. So if your hierarchy is quite complicated, you can you can now use this two parallel hierarchies and to constrain them both with these sealed interfaces. Sometimes, not very often, but sometimes it can be useful. And another use case when sealed interface become really handy is constraining implementations of an interface to library only. Since all the subclasses should be located in the same compilation unit, it automatically means they could only be defined inside the library. For example, if we define an interface job from the Kotlin X coroutines package as sealed, that forbids extending it outside the library. It was always an intention, but it was impossible to restrict it by the compiler before. So now with sealed interface, it's possible, and also for it's a feature that might be used in other libraries. Now let's talk a little bit about correspondence between this new feature in Java and in Kotlin. Sealed classes got supported in Java 15 and on JVM as a preview feature. In Java, you must explicitly list all the subclasses of the given sealed class or interface after the permits keyword, as you can see in this slide. Then JVM recognizes sealed classes at runtime. Permitted subclasses of a given class are stored in a new attribute in the class file. The name of this attribute can still be changed. Thanks to this information stored in a class file, JVM can check whether a given subclass is allowed, whether it's listed in the permits list. JVM therefore forbids not authorized subclasses. You can't define a new one not mentioned in the superclass permits list. In the future, Kotlin will use this new JVM support for sealed classes and interfaces. So when you compile Kotlin to the latest JVM version, this new support can be used. Kotlin compiler will generate permitted subclasses list in the bytecode to enable the underlying JVM checks. But in Kotlin, you don't need to specify explicitly the subclasses. So there is no permits list, permits annotation like in Java. But the compiler can extract this information from your code, from the declared subclasses in the same package, and generate the corresponding list under the hood in the bytecode. However, if you would like to have the similar explicit list as in Java after permits as an optional specification, please share your use cases and the reasons why you miss this functionality. It then can impact the priority and the necessity of such feature. So far, it's not planned, so far the Kotlin compiler will just use this information from the code. One thing to add about mixed hierarchies and mixed project, please don't define mixed Kotlin Java sealed hierarchies. Kotlin compiler won't know about Java subclasses. At the moment, Java class can't implement Kotlin sealed class because if you try, you'll find out that it just says the constructor is unavailable, something like this. So it can be enforced by underlying bytecode implementation. However, it can't be enforced for interfaces. So theoretically, in Java, you can implement Kotlin sealed interface. So just don't do it. In the future, with the new JVM support, it will be forbidden. Java class will be considered as a legal subclass to Kotlin interface, or if there is this annotation, probably you will be able to specify this. But the plan is that when it will be able to enforce that by JVM, it will be enforced. But for now, theoretically, it will be possible. However, we'll add ID warnings to prevent doing it by accident. I'm looking for some questions. I see none so far. So then I think I will continue with my next topic. And if you have any questions, please post them in the chat. I will reply to them, answer them later. So our next topic is inline value classes. And first, I want I'm going to remind you about this functionality about inline classes, and then we'll talk about how it changes. So let's start. In simple words, an inline class can wrap a value without any additional overhead. This feature has been available for some time. It was added in an experimental state in Kotlin 1.3. And Kotlin 1.4 is going to stabilize this functionality with some changes. I want to use time duration API as an example to define a problem and discuss the alternative solutions. Without inline classes, duration can be implemented either via primitives or using a regular class. Let's try primitives first. We need a function that does something after giving timeout. How to pass the timeout parameter? We can use primitives, like long. However, it might be really confusing on the call side. We pass an integer constant, but we don't know immediately whether it's seconds or milliseconds or minutes. It's not a type-safe solution. We could sort of overload this function, adding the time units to its name. But it's too verbose, too long names, and again, not the best solution. Defining a duration class solves the type safety problem, and it's basically the solution suggested by all the object-oriented practice. We can define even extension functions, extension properties in Kotlin, like int seconds or int minutes, to emphasize the time units. It's no longer prone to use this new greet after timeout function. Yeah, so we have explicit units in the code. Great. The only problem here is that an extra object is allocated to store the duration. So after getting type safety, we lost performance. And inline value classes solve it. They combine performance of primitive types and type safety of regular classes. Starting from 1.5, you define an inline class differently, as a value class annotated with the JVM inline annotation. But the concept is the same. Under the hood, the compiler replaces the duration parameter with long. That means no extra object is allocated when you pass a value. In this example, the compiler replaces 2 seconds with a corresponding constant in the bytecode. That's what I mean by saying that inline value classes combine performance of primitive types and type safety of regular classes. No extra objects are allocated. It's primitives under the hood. And explicit units in the code demonstrate the type safety. Duration is represented by a separate type. It's not any number. Note that the duration class has been available in the Kotlin standard library for some time in an experimental state. But it's different from what I'm showing here, since it stores the value as double property, not long. I used a simplified version of the presentation for clarity. Inline class is a wrapper for only one property, and this property should be read-only. That's what is changing. Before that, defining mutable property was allowed. An inline class can be a wrapper either for a primitive or for any reference type like string. So all is possible, all works in the same way, the wrapper is eliminated when possible. However, the wrapper is not always eliminated in the bytecode. It happens only when it's possible. It works very similar to built-in primitive types. When you define a variable or pass it directly into a function, its type gets replaced with the underlying value. Here, during the compilation time, is duration, but it's replaced with primitive in the bytecode. If you store a duration value in a collection or pass it to a generic function, like in this example, it gets boxed. Boxing and unboxing is made automatically by the compiler, so you don't need to think about it, but it's useful to understand how it works. Basically, it works, again, similar to just primitive types. So the logic and the idea is the same. In Kotlin, you don't have boxed or primitive types, but under the hood, the bytecode level, they are still there. Nothing changes. It's very similar to Java, but hidden by the compiler. If a function takes an inline class as a parameter, its name is mangled. That means the compiler adds a suffix, again, like in this example, to its initial name. That happens for two reasons. First, that allows overloading a function taking two different line classes that wrap the same value. So like two different line classes wrap along, and you might want to define this overloads. So without mangling, it would be a compiler error. Yeah, like in this example, we have two different record functions taking name and password as parameters. Without mangling, they would have the same JVM signature and the bytecode, and such code won't compile. But here under the hood, because they have different names, Kotlin compiler has no problems with these declarations. The second reason for mangling is to refrain its accidental usage from Java. All Kotlin usages are type safe. You can only pass a correct type, like duration in this example. But if you use it from Java, you can have the same confusion problems as with using primitive types. So you can pass long and be confused what are the units and so on and so forth. But if you still want to use it from Java, there is a workaround, an explicit workaround with which you say, yes, I want this function to be called from Java. You provide an explicit JVM name for this function. It changes the underlying name in the bytecode and makes it visible by this name and usable from Java. So again, this is explicit intention that saves you from accidental usages which might be confusing, right? In this case, you are saying that, yes, I know what I'm doing. If you follow the language changes and were using inline classes before, you might be wondering why the syntax changes. It was inline class before, but now it's value class annotated with the JVM inline annotation. Why? Inline classes now become a part of the bigger story, a case of a value class with a specific optimization. So now let's talk about value classes. Disclaimer: value classes are not yet supported. What I'm going to share now is the future vision and the reason for syntactic change with inline classes. Value classes will be properly added to Kotlin in the future versions. Again, this syntax doesn't yet work, but it's planned to be supported in the future. The idea of a value class is to represent an immutable entity with data. It can contain many values, not just one. But all of them should be read-only vals, mutable vars, and allowed. Value class is primarily a data holder without identity. It's completely defined by the data stored. Identity checks are even forbidden for them. And that allows major future optimizations. You've probably already guessed that it's connected with the upcoming Valhalla project. Valhalla project is a big future change in both Java and JVM. Its model is similar to what we've discussed about inline classes. Codes like a class, works like an int. But the goal is to combine the benefits of performance of built-in primitive types and the type safety of the regular classes. And that comes with the native JVM support. Let's dive into details. I will use the Kotlin terminology, say value classes, but assume they are implemented as JVM primitive classes under the hood. First, let's compare them with regular data classes. I define point as a data class data point to distinguish it from value point from the next slide. When we define two data points, the corresponding objects are created in memory. The variables point1 and point2 store only references to these objects. Kotlin optimizes equality and calls equals under the hood on our behalf, which compares their underlying data. But we can also check the reference equality and compare two references. Since they are different, such check returns false. Values stored in variables are highlighted in green. You can see they are constants directly for primitives, but references for all the reference types. The major upcoming change in Java and JVM is that now values of primitive classes, or in Kotlin terminology, value classes, can be stored directly. The value classes are going to be stored in variables on the computation stack and operated on directly without headers and pointers. It's a huge change in JVM, and that explains why it takes so long to implement it. Since there are no references, the whole idea of reference equality is no longer valid. Let's now compare how we pass a data point and a value point as an argument to a function. In the first case, the data point object is stored in memory, so the compiler puts the reference on stack when it passes the argument. In the second case, the value point gets passed directly. Now this object becomes data itself. Note that since there is no memory occupied, there is no state, and value class can't be mutable. One of the main reasons to support this new concept on JVM is to enable flat and dense layout of objects in memory. Area of reference types is always an area of references. That leads to the practice to define two different arrays of primitive values to store both coordinates x and y in a performance-critical parts of code. Project Valhalla addresses that with introducing primitive classes. JVM will be able to optimize such storage for primitive classes, again, in Kotlin terminology, value classes, and flatten that. So in this slide, you see that the second representation of array of value point is flattened. X and Y are defined directly in memory as a flattened layout. So that all sounds cool. When? There are a series when Project Valhalla lands on JVM. As you remember, I promised you to share the future vision and the motivation of why inline classes are now value classes. We are really anticipating this upcoming JVM change and want to benefit from it in Kotlin. But before that, we don't want to block our users from benefiting from this new functionality. Inline classes do work now, and they'll be stable in Kotlin 1.5. Note that JVM inline annotation and the whole primitive classes optimization story are JVM specific. On other backends, the underlying implementation is going to be different. For example, analogs of Swift structs for Kotlin native. There is much more to value classes, and that also explains why we do want to have this functionality even before the major JVM changes. Modification members is a concept already working in Swift, and that works perfectly in theory with Kotlin immutable value classes. However, that's out of scope of this talk, but I want to redirect those of you who are interested to the talk by Roman Elizara from the Kotlin 1.4 online event, where he, among other plans, covers or future directions covers these modification members. We have discussed the new upcoming features. They are available in Kotlin 1.4.30 or in Kotlin 1.5 milestone 1. So please give them a try. Your feedback is really important to us. If you want to learn more details about what I've covered today, first of all, check the the detailed design documents in KEEP. They provide the general description for the new features as well as implementation details. For instance, you can find the very descriptive document on Kotlin value classes design. We are also publishing this information in our blog and in our documentation. So in block incubation, there is more what's already there, what's released, and contains mostly the plans and the design documents of the future changes. But you're welcome to join both discussions. And there are specific UTrack issues around these features and other issues on the Kotlin roadmap. Check the roadmap link to find the UTrack issues links and see what's there. So again, I want to repeat that your feedback is really important to us, especially for the pre-release features that we're going to stabilize in 1.5. And you can really influence the Kotlin evolution by trying new features and sharing your feedback and your use cases. So that's all from my side. Thank you for your attention, and let's Kotlin. So I think we're back from the presentation and can see your questions if there are any.
So if you folks have any question about Kotlin 1.5, the future, how to contribute, etc., Svetlana is your person.
Yep, probably you already know it, and please don't hesitate to share your thoughts, your feedback. Come to us to all the resources. Even if your comment is not answered directly by someone, it doesn't mean that we don't read them and they don't impact their further evolution. So it's like all important. So yeah, I think if there are no questions, we can move on, probably.
Okay. Well, if they want to reach you later, Svetlana, I guess they can contact you on the Kotlin Slack, Twitter, probably, right? The typical channels.
Yep. Absolutely. Yeah, and probably I will follow the thread for some time. So if you have any questions, I'll be able to answer them.
Okay, folks. So if you're side, please write your questions on the chat, and Svetlana will be able to check them out during the meetup.
Yeah. Thank you. Then.
Yes, Svetlana, thank you so much for being here, and hope we can greet you again very soon.
Thank you.
Bye-bye. And last but not least, our cowboy, Nika Skelton.
Howdy, folks.
Very famous person here in the community, cowboy on his free time, as we can see. And,
yeah, nice to be here.
So what's up, Nick?
Yeah, not much. Got a bit of a talk about Flow to give you guys today. Hopefully it's not too late for everybody. No, it's 7 o'clock and you're probably aching to get a beer into you. But yeah, I wanted to just jump straight into it.
Yeah, let the flow roll. You have a presentation that you want to share?
Yeah, let's do it. Hold on. Share my screen.
Okay,
right.
So Kotlin Flow, A New Hope, Nika Skelton, GDE freelancer, master of all Kotlin and Android things. The flow is all yours. Good luck, and folks, if you have any questions, like always, feel free to write them here on the chat. Nick, everything yours.
Thanks a lot, Enrique. And it's good to be back in Munich again, even if it's just virtually. Right, so what am I going to talk about? Flow. So, okay, first of all, there's the link to the code if you want to follow along. Not really entirely necessary. I'll show you that link right at the end. I'm going to be doing some code demos and going through the code as well. But yeah, what's the whole deal? It's a bit of Star Wars. So let's go back to a galaxy a long time ago. In an old project where I used to work, we came up with this little tiny app that I'm about to show you as a way of, giving it to our prospective, team members as a way of sort of a little playground where they could show us their skills. So part of an interview process, basically. The idea was to give them something that sort of mimicked our own code, but wasn't exactly our own code. And then, had the same style, same technology, same architecture. And yeah, I dug that project up. It's yeah, a long time on the scrap heap. I picked it up and decided to use it as a way of playing with Flow. So we used RxJava back in those days, and yeah, I thought it would be cool to sort of revive it and use it as a playground for Flow. So that's kind of where this comes from. Now, the title here is A New Hope, but I really just used that because of Star Wars. You know, Flow and RxJava are like not hot competitors, you know, like Microsoft and Apple or something like that. And I think this quote here from Roman like really explains that really well. You know, the guys from JetBrains basically said, like, we're more or less standing on the shoulders of giants. You know, they've always used RxJava, and they with the advent of coroutines, they sort of thought, let's see if we can like take RxJava and do something different or better with it. You know, like bring it into the future somehow. Yeah, and that's all I wanted to say about that. I'd also recommend following Roman. He's it's really interesting to read his articles because you kind of see the intentions behind the technology, like why they're doing it, not just the what. So I really recommend reading some of his articles. Anyway, back to this app. So this is what it looks like. Really beautiful. Definitely weren't many UI focused people on this project. But yeah, it's basically we have a list of people on one side and their details on the other. Pretty straightforward. It uses the Star Wars API, which is open and free, so anyone can use it. It's online, and that's more or less why I chose it. And it's fairly simple to follow, just like a nice RESTful open API, free. That's what it looks like. Now, first task was to extend. And yeah, it's a little bit facetious what I've written here. How well can you copy and paste? Actually, it's kind of a deep question, even though it sounds very, you know, sort of shallow. You know, you sort of, when you're a junior developer, you learn to copy and paste things from Stack Overflow, right? And there's the skill to like copying stuff and shoving it into your app and making it work somehow, right? It's a skill that everybody has and everyone uses if you're working in any sort of like production application. Like as you get older, right, or as you get better at coding and you become a bit more senior, the idea behind copying and pasting shifts a little bit, right? So you obviously don't just copy and paste blindly anymore, but also it becomes like a skill to be able to adapt to a new project, right? So when you come into a new project, you'll come from another project where maybe they had a completely different style, right? Maybe they used the text and now they use KTNet, right? You know, you have to adapt to that, and that is also a skill, I think. So being able to come into a new project, identify their style, and copy and paste it, right? And that's kind of what we were looking for here with this task, right? So the task was just to add some more information to a screen, to the detail screen, body weight index, body mass index, right? Which is just the weight divided by height. Very straightforward and simple calculation. Yeah, that's the first task, right? Just extend the app a little bit. And here's a beautiful little animation that I made in Keynote, where you can see that we have the height and we have the mass, so we can actually do something with that. Code, that's my reminder to code. Now I'm just going to turn this funny little guy off because it's sucking up my CPU. Can you still see me? Maybe not. Let me just change that. Okay, that's the real me. much less good looking. Now, code, much better to look at. So, okay, here's the app itself, laid out very, say, simply. We have a service layer, some DI modules. Actually, what's interesting is I have a fake API service here, so I can sort of swap out between the real service hitting the real API and then a fake API. Just because one time I was doing this presentation that the real API went down. You know, it's a free open API, so it doesn't really have quality of service. And so yeah, I created a fake one just in case. And then we have the UI, right? So we have the UI that we're going to focus on the person, which is like the details, display or screen. So we have a view model, like a fragment and a view model, view and view model. And you can see this is our contract, right? Literally a model of our view, a bunch of flows, which is kind of cool. I really went all out and said no live data. Like I really wanted to just do all of this with flow. So instead of using live data and observing things in the fragment, we're actually exposing flows here, which is really cool. And if you're interested in how that works, there's a whole bunch of little extension functions here. So in the fragment, we're just binding to these very fine-grained flows. And we're doing that with these cool little extension functions here. That's not really what I'm here to show you though. What I want to show you is the view models. Now I have like one for each task, more or less. So I'm going to show you task number 1 first. They all implement the same interface here. Right, so here it is. What am I going to show you here? Okay, I've actually already done it. That's body. Let's just show you the app, right? Let's just build and show you the app so that you can see that working. See what it actually looks like. That helps. Okay, so there's our real app. We're actually hitting the real backend here. And there's the sort of core application just working, right? And we need to implement the BMI. Now, that's also wrong. Okay, so we have a flow here, right? A flow of person. This is kind of like our source, if you can think of it like that. So I really like the name flow because it you know, the way that I sort of write reactive streams with like this this whole idea of like unified unidirectional flow. It really is a flow, right? So this is kind of like the head of the river. The person is the main flow, and then all these little tributaries are like they flow off of the person, right? So you know, the fragment comes in and it says, I want the name, and the name says, okay, well, if you want the name, you got to go get the person. And up here it says, okay, if you want the person, then you have to go to the service, right? And then we go to the service and we either get a success or an error. And if we get an error, we should probably do some error handling, but that comes later. Yeah, so the idea here was to implement the BMI. That was the first idea, first task. And voila, I've just done that here by uncommenting some code. It's really nice if that was how it worked most of the time. Nothing too crazy here. This is what I mean by extending what's already there. You know, really what we're looking for is just like another single line of code, right? Something that looks very similar to the rest of the class, right? All these properties, the same sort of thing. Okay, good. There's some like calculations that need to be done. So we have a little extension like value here, extension property with some cool big decimal and blah, 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 whatever. That's cool. This is sort of mainly what I'm looking for this task. But you do get some extra points if you noticed some something that if you ever used RxJava, you probably would notice this as well. Same thing happens with RxJava, right? Now you can see here, okay, we've gone and got Luke Skywalker, the BMI is calculated, blah, blah, blah. What's interesting though here is that you can see that, well, maybe you can't see. Let's try to make that bigger. There we go. Yeah, so you can see here that we've gone and got the person 4 times, right? Person, that's the ID, number 1. We've made 4 calls to the back end, right? Which is no coincidence that we have, you know, four properties here, 4 flows, 4 calls to the back end, right? It's because each one of these creates a new flow, right? And so, yeah, what we want to do there is share this flow. So this person is shared amongst all of these properties, right? And that's again, that's another little cool extension function, which can be used in the whole app. Anyway, so that's task 1. That's like, you know, 100 bonus points if the person actually noticed that as well. Okay, that's task 1 done. Let's go back and go to task 2. Now, I don't know, I still remember like what it was like learning RxJava, and I mean that's really the only. I know live data is also reactive streams as well, which I've learned since then. But like RxJava is definitely the more powerful and more advanced version of reactive streams, and FlatMap was like something that it took me a while to get that right. It took me a while to really, you know, understand how to use it first of all, and then understand where to use it and what it does, right? And it really separates, like, it's really the answer that you give to explain a flat map is really important when it can really separate the people who understand reactive streams and the people who don't, right? And I would say it's like sort of an intermediate level operator, like where you start, when you start to understand flat map, you're really starting to get reactive streams. And you know, people learn different ways, and for me, I learn best with an example. And if someone had given me this example back in the day, then I would have really loved them, right? So this is a perfect use case for a flat map, is what we're about to do, right? So we need to get the character's person, like their object itself, and then we want to go and get their planet as well, right? So we get the person first, and we can't go and get their planet until we know which planet to get. So we get the person, and then we go and get the planet. So this, yeah, like it says, you need 2 calls, get the person, and then get the planet, right? And just to take a look at the data, so that makes a bit more sense. We have Luke Skywalker here, and we have a field that has a link to his home world, right? So it's very similar to like a SQL join, right? Like this is like a foreign key, you know, telling us what Luke's planet is. And this is what we want the UI to look like. Yeah. Now, I'm going to combine this, just in the interest of time, with the third task as well. And the third task is just like full-on crazy talk. And it is to show all the films as well, right? So not just the planet, but all the films that the character has starred in, right? And that's like, you know, it adds like, you know, 4 or 5 levels of complexity to it, right? Because first of all, we're going to get the character, which we've already done. That's cool. And then going and making an extra call to go and get the planet. Cool. All right. You can kind of think, yeah, that's okay. It's not too bad. But now we have to make a number of calls. It could be none. It could be 10 to go and get all the films, right? And this adds like a new level of like, okay, what do we do with that? So how do we make that work? And yeah, the operator for that I've used anyway, like this is all just the way I've done it. I used scan, right? And scan is like, if you know how to use scan, I think you're a wizard, right? It's a really powerful and cool operator that allows you to do some really radically advanced things. And in this case, it allows us to create like a string, you know. And I really like pushed it, this idea to try and make the UI not just look correct, but also act correctly in cool ways. And I did that by combining scan and flat map and exploring the whole set of operators that Flow provides. So let's check that out. Let's have some fun with that. Okay, first of all, flat map, right? Just to explain flat map. So we're going to go over to the second view model, the second implementation, and it's a little bit different, right? So now we have this. Now our source is not a person anymore, right? We still have person down here, right? But we also need the planet as well. So we have our little tributaries down here, and there's lots of words for this. Like I think the best one that I like is this is like reducing code, and it's super fine grained and very easy to follow, right? It's almost like a configuration file. It's not even code, right? But we have a person, and the person flows into the person properties. We have a planet flow, and that divides up into all the different planet strings or planet properties. And then, yeah, this films and extra stuff is going to come later. But how do we get that? Now, even though I have called this state, one thing that's really cool to notice, and something that I've purposely tried to do, is to not keep any state at all in this view model, right? So you see that there's like a real lack of like, you know, there's no like mutable state flow here. There's no like mutable properties. There's no state, right? So this whole view model, I'm trying to make it as stateless as possible. It's almost like a pure function, right? You know, like it's still reactive streams and it's still objective oriented programming. So there's some like, you know, crazy functional programming idealists in the audience. You're gonna groan when I say that, but like the idea is to move in that direction as best as possible. So yeah, even though I've called this state, it's more like a container, right? We have a container that's got a person and a planet inside it, and yeah, all we have to do is fill that up. When we fill it up with a person and a planet, then all this code here just takes care of itself. It's just like all the little tributaries suck up all the data and spit it out the way they want it. So how do we do that? You can see this glowing yellow operator here is flat map. Flat map concat, right? So very similar to before. You'll notice that this looks very similar to what we had in the previous one, right? Get person, result, success, result, error, right? It's more or less the same here, except now we have this flat map. What the flat map means is we're going to go and get the person. And every time the person emits a person, we're going to go and get the planet, provided that it was a success, right? The idea is that we're sending back, instead of an object here, we're sending back another flow. That's basically what flat map does, right? Converts one flow into another flow, right? So now get planet, you can see, actually sends another flow back, and then this guy just sends back an empty flow, more or less, an empty state, an empty container. Right, again, we've still got the little share there, which allows us to share it between all these other guys. And then get planet looks more or less the same, right? So we have some end paths, 3 sort of ends you can call to our flow, where the flow more or less completes, you can say. We have here, so if the first call to person fails, then we can't go and get the planet. It's not possible, so we just send back an empty state. Again, not ideal, but that's just we're doing something, right? Here, when we have when we go and get the person's planet and it's a success, then we're in the happy path. We have the person and the planet, and we can send back a state that's filled with both. Here, we're kind of doing something half cool, which is, well, we couldn't get the planet, but we got the person, so just show the person, right? And yeah, that's what that looks like. Let's see what it looks like in real life. Oh, bloomp. There it goes. Now, not great, right? I mean, it's, you know, we have, like I said, we have to go and get the person, and then we're going to go get the planet. So really, shouldn't we be showing the person first and then the planet? You know what I mean? Like at the moment, it just shows everything all at once. Just like when it's all finished, bleh, right? But actually, we have this information earlier than we have this information. So why not show it? Right? It makes a bit of sense, right? And that's the kind of that's the kind of thought process that I went through for the third one, right? So the third view model is much bigger, and we're doing lots of crazy stuff here, right? So it's a lot of code. Some of it is just like different versions. So I've got like 2 versions here that does the exact same thing. I have a refresh mechanism, and we've got loading and error stuff. All looks pretty crazy, but I'm going to break it down a little bit for you. So first of all, we have a different state. So our state is holding a bit of extra stuff here. And this is also not ideal, honestly. Like in general, I would usually, keep things like person and planet out of the state. Like the state can either represent like, let's call them like business models, right? So you keep business models in here, which is okay, right? Or these itself, right? So you could model your view state in here as well, right? So this is kind of like a mix, which is not ideal, right? So like, for example, why am I using planet here and I'm not using films here, like a list of films, for example? So there's some optimizations to do, like architecturally wise. But yeah, for the moment, it's a container, right? It holds all the information that we need to create our subflows here that we're going to show on the screen. So let's go through it. And what I'm going to do here is kind of again explore a bit more of flat map, because that's one of the cool things that I liked about Flow was it forces you to choose a flat map. Thank you. It forces you to choose a kind of flat map, which is really interesting, because I didn't understand the differences between these until I started to explore them. And what I've done here is I've set this up so that you can really see the differences in the UI, right? So like what I show you here will all I do is change some of these flat maps to different types, and you'll see the changes themselves. But let's just quickly go through what happens here. So it's very similar to before. We have a get person details now. So now we're sending back a little bit more information, right? So instead of just the planet, we also want to go and get the films. And because we're getting we get the person, once we get the person, we can go and get the planet and the films all at the same time, because we have the information that we need. So that can, in theory, all be done in parallel. We don't have to get the planet first and then get the films. We can do it all in parallel. So let's show the first one, no progress films. What I'm doing here is combining kind of two flows. So we're going to go and get the planet. That's one flow. And we're going to go and get the films. That's another flow. Right? And we're combining those together and then building our state at the end, very much like we were before. Right? So here's our happy path ending. Right, where we have the person, have the planet, and we have a string of films. Right? And then we have all these little on start things hanging off the ends that allow us to show loading and to put person in the place, so that you can see the person before everything else, like I was saying before. All right, let's check it out and have a look and just see what that looks like. And then we'll start messing with some flat maps. Okay, first I'm going to, I'll show it to you. This is the real API, so I'm hitting the real backend here, which, okay, cool. It's not going so fast. But you can see here that this is, it doesn't really seem to be doing these in parallel, right? It's doing one after the other, so it seems it's quite slow. I'm just going to swap over to use the mock service, because it slows everything down a little bit, so you can really see it a little bit more clearly. Oh, it's so slow, right? And there's lots of things wrong with this, right? So it's slow. It's obviously doing one after the other. Right? It's going and getting a New Hope, then it's getting Empire Strikes Back. Once that's done, then it's going and getting Phantom Menace, right? But the worst thing is I can't actually tell whether it's finished or not, right? So I don't know if that's still going or whether it's, or what's going on, right? So that's something I tried to deal with. And here we are here with this no progress films flow, right? So we're still doing some running reduce, which is scan, another word for scan. But yeah, what we're doing here is we're getting a list of the person's film IDs, converting it to a flow, and then flat map concat. Now, what does concat do? Okay, here we're basically getting a flow here, which is something like 1, 4, 2, 5, 6, right? These are IDs that the person has started in, right? And we have them all straight away, right? So this flow is not like a slow flow. It's just like boom, 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 boom. It sounds like five emissions, one after the other, straight away, right? What this does is it totally slows it down. It says, okay, let's go and get this film. When this whole thing is finished, when this flow here is finished, then we'll go to the next one. And then we'll go and get 4. And then we'll go and get 2. And then we'll go and get 5. And then we'll go and get, well, 5 is bad, 9, right? Okay, so let's change it. Let's try the other one, which is latest, right? And generally, when you're learning flow, I found this anyway, always reach for the latest, because most of the time that just works. Like if you're a lazy programmer and you don't want to read all the documentation, well, first of all, you're an idiot. Don't do that. Read the documentation. Really, the documentation inside all of the coroutine stuff is really, really like concise, to the point, and has examples, right? It's really, really useful. It's not just like, flat map latest, what it does is it maps the latest emission into a flatter emission, right? Like it doesn't just repeat itself, it tells you exactly what you need to know and what's interesting, right? So it's useful documentation. I really recommend reading it. But in this case, this is definitely the wrong one to use, right? Because what's going to happen is it will basically discard all of these four and just use this one. Because these all flow in, bang, 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 in quick succession, it's going to start each one, but cancel it straight away because a new one has come in, right? So it's just going to do the latest one, which is going to be 9. Not so great. And we can see that if we play it. Let's see what happens. We got the planet, now we're loading at least. We got a loading indicator. And we just got the last one, Revenge of the Sith, and we're done. All right, so latest is not the right one. And then the only one that's left is merge. And merge is really a powerful one. It can also be bad, you know, so each one has its own use case, right? But if we don't care what order these come back in, right? So if we go and get 1, if you know we shoot get film out, we go get film 1, get film 4, get film 2, get film 5 and 9. Just go and get them all at the same time, and then 9 comes back first, and then 2, and then 5, and then 1, and then 4. It doesn't matter what order they come back in, then merge is perfect, right? That's what we're going to use, and that's what's going to happen. So check it out. A little bit nicer. Boom, 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 boom. You can see they all came back one after the other, right? Much nicer, right? Much more parallel stuff happening there. But still, couldn't really, there was like, you know, there's a moment there where I'm like, is it finished or is it not? What's happening there? You know, at this point I kind of went like, it's a bit silly because actually we know, right? Once we've gotten Luke Skywalker, we know that he's in 6 movies, right? And actually one's missing here, right? Which is here, right? So if there's an error that comes back, we just get a null and that just gets lost. Right? So we're not showing any errors. It's one bad thing. But also, we know that there's 6. So we could potentially show all of those 6 there, and then just, as they come back, we change their status. And that is what I did in the next, this one, progress films flow, right? So it does more or less the same thing. It just does it with a couple of extra cool UI features. Now it doesn't look particularly amazing, right? So don't laugh at that. But you know, the UI is something that this provides the information that the UI could then use to do something cool. So now we have loading. That's cool. We have this indicator that's telling us that something is happening, at least, right? And again, I've gone back to flat map concat here, just to sort of to show the sort of serialization that concat brings. It does one after the other. So we're going and getting Empire Strikes Back, and we try to get film number 3, and that fails. And now we're trying to get this one. It's very like, serial, one after the other. But at least we have this loading thing, and we know that there's something else coming. That was the cool thing. And now we're finished. Cool. That's progress, man. But we can do better. Let's do the same thing that we did before. So latest obviously is totally a mistake. It's just, you know, this worked with concat. Latest breaks it because we're only going to show the latest one. So let's try it with merge, right? And this is kind of the one that I like the best, right? And here we do stuff like scan and map, which I can show you if we have time. But this is the sort of final product. Okay, so don't laugh. Boom. Right, so a much nicer sort of, let's say, not aesthetically pleasing to look at, maybe, right? You don't want to see like 6 different loadings on the screen, right? But at least like the whoever's designing the UI has that information, right? So it's like we know that there's 6 loading and we can do something with that, right? And here's a little refresh mechanism. So the refresh mechanism is maybe worth showing just because I want someone to tell me a better way of doing this. So I have a trigger here, and I don't like it because it's the only val, it's the only sort of piece of state that I have in the entire model. But everything basically is based on the trigger, right? So state changes whenever the trigger changes, and that allows us to do a refresh. So to basically trigger this entire flow to run again, right? And that works just by, this is a shared flow, but we could change that to these days we could use a mutable state flow instead. Whatever, same thing. When the user presses refresh, it's just going to dump an extra value into the trigger, and then that triggers a new flow. Yeah, and that works, but I don't know. It seems a little bit dirty to me. Maybe there's a better way. Yeah, and if there's a better way of doing anything that you've seen, please let me know. It'd be great to hone my chops. Yes, so that is more or less it. I can quickly go through the scan and map stuff if you are interested in this wizard stuff. So what I'm basically doing here is creating like a little table, so a map, right? Creating a little map, and you can see in here, this flat map. Every time I go and get a film, I'm creating a little entry in the table, right? So film ID to something, right? It's a string. It's always a string, right? And if it's a success on our happy path, then I'm creating a film string, right? Which is something like, A New Hope, brackets, 1970, whatever. If it's an error, then I show an error, film ID to error. And then here on start, I'm like film ID to loading, right? So this whole block here is emitting a whole bunch of pairs, right? Little like key value pairs, basically. And the scan is just shoving them all into a mutable map, right? So I'm just replacing or adding the key value pair into a sort of a rolling database, right? So that's what the scan is. It maintains like a rolling database of film ID to whatever its current status is, whether it's an error, loading, or success, right? And that changes every time a film comes in. It emits whether it's loading or whatever. It updates the table, and then I take that table here and convert it into a string. So this is more or less a string builder. You can think of it like that. It takes all the values, which is like either a film string, an error string, or a loading string, and it just puts them, makes them comma separated. Right. That's it. It's I don't know. It's a bit of mental gymnastics, personally. I it's very hard for me to say whether that's easy to understand in a conference or not, especially because I just can't see your faces, so I can't see whether somebody is going or yeah, get on with it, you know. So yeah, feel free to ask me questions about this stuff, and also feel free to show me a better way of doing this. There's for sure probably like an operator that just does this for you, which would be really cool. I'd be totally interested in optimizing this. Anyway, that's the code. Let's go back to the presentation because we're more or less done. Some sort of passing thoughts on Flow itself. So migrating, you know, Flow, Live Data, and RxJava are all interoperable by definition, right? They all adhere to a very simple interface. So at least in theory, they should all be able to be interoperable. You should be able to convert from one to the other and back. And you know, there's extension functions, libraries all over the place that do exactly that. And actually, I have another project where I have a very complex state machine that's built with RxJava, and I've just got all the inputs and outputs, you know, kind of cordoned off, and they're converted into flows on the outside, and it works really well. I'm not going to say it works all the time perfectly, right? I mean, but in that project, it works really well. Testing, I just wrote an article on testing, which you can check out. It's but the too long didn't read is use Turbine from Square. It's really the best solution I found. And then exception handling is the same as coroutines. There's a great article by Roman on that. Yeah, here's some useful links. Check out the coroutines GitHub project. You know, you can see why, again, like to go into more detail about why they're doing things, you know, like some of the things that Svetlana was saying, you know, like how you can get involved with how Kotlin is being built. It's really true. Like if you go into the GitHub projects, they're super active and you know, they really challenge your use cases. And I love to read those threads. They're really interesting. Yeah, there's my code, and there's Roman's code, and then there's the Star Wars Open API in case you want to check that out too. That's it. I'll leave that up there. But yeah, thanks for having me again. Kotlin Munich, and may the force be with you.
Well, thanks, Nick. I have to say I like more your cowboy look. But,
yeah, instead of like, oh wait, this isn't even my house look, you know. Yeah,
nice.
Yeah, fun, man.
Yeah, so if any of you have any question about Flow, last actually recommended like or sort of de facto standard for Android, right? And you want to check with the master, it's a little bit like say something now, or well, they don't need to set up forever. They probably can contact you on Twitter or
yeah, definitely. Yeah, I forgot to put my Twitter handle up there, but it's just nshred. You'll find it. Yeah,
I think if you Google Nika Skelton on Twitter, they'll probably find you.
Yeah, ignore the guy who rides a horse. That's not me.
Okay, folks, any question? If there are no questions, it seems so. I think our March meetup is over. So thanks everybody for coming. Christian, let me bring you in. So, well, thanks everybody, Svetlana as well, in her absence, for being a part of the Kotlin meetup in Munich. We're so lucky to have so many experts in Kotlin and doing a lot of really cool stuff at the moment. So yeah, I hope we can have you again. Nick, you've been a few times, but of course, the more the merrier. So if you can come in the future, that would be super nice. Christian, likewise. Thank you also for Novatech. for proposing the meetup. So actually, Novatec, that's your company, Christian. They were proposing us to have this meetup, and they sort of organized it a little bit. So we're super thankful for that. And Tobias Preu says, thanks a lot. Greetings from Berlin. Hello, Tobias. Thank you. So this will be this has been recorded on YouTube. You'll have access to that later if you want to check anything. And thank you for being here, and hope to see you in April or in any of the upcoming meetups.
Thanks as well. Thanks, Enrique. Thanks, everyone.
Thanks, Christian. Thanks, Ricky. See you later, guys.
Bye.